Alright, we are going over the math that I discussed yesterday in regards to Dr. Ruth E. Kastner's concept of the space-time interval, whereby she is using the space and the time as the squares and then subtracting them as a constant for the de Broglie law of phase harmony, such that the quantum frequency equals the Einstein kinetic energy based on the speed of light squared. And so what I've been doing is comparing that with Alain Kahn's use of the fact that the wavelength is now defined by a quantum inverse frequency and no longer by a spatial measurement. And so I'm going to be analyzing Kahn's application of that non-commutative inverse frequency concept for the non-commutative torus of the block sphere. So here we have this is from the PDF here of on his non-commutative geometry that he co-wrote. And so you can see here that he's discussing the music theory based on the simplest music transposition of the Pythagorean 2 and 3 as the perfect fifth against the octave as the scale. So as I've quoted before, he is talking about the difference between the scale as the spectrum based on 0 and infinity, and then the chord, the non-commutative chord that's within the non-commutative torus. And I have images of that elsewhere on my blog, but I'm just gonna focus on the math here right now. And so we can see that we're talking about these inverse, where's my mouse here, the exponentials. And if you take he's talking about the quotient. So the quotient is this, what a quotient is in logarithms is subtracting the inverse of the exponentials as the logarithm. So we just have the first one is the exponentials as the capital P, and then the inverse is the cross product. So you have okay, so we're taking that quotient is based on those discrete music ratios. So you have the in this case it's 2 to the 19th and 3 to the 12th, and then the inverse then is 3 to the 1/12th and 3 to the 1/19th and 2 to the 12th. And that way, when you subtract them for the quotient space, then you are getting 3/2 to the 1/7, because you're subtracting the ratios, the inverse of the exponents. And so that is is a convergence that's always greater than 1. And therefore, we then plug that back into his equation for a constant, his constant equation based on the inverse of the wavelength. So you have a negative wavelength here as the inverse. So you have the wavelength to the -1, so it's an inverse wavelength. And since it's a negative number, because it converges, the wavelength converges as the inverse frequency, so it's an inverse of the exponential as the wavelength. And since it's greater than 1 as the convergence, then when you subtract the 1 minus the greater than 1, then it's always less than a positive number. And therefore, it always has a geometric dimension of 0. So then we can go back to the Kahn's quote from his Music of Shapes lecture, his quantum sphere lecture, and we can see he is using both the exponential 2 to the power of 19 and 3 to the power of 12, and also the inverse of the 2 to the 1/12th and 3 to the 1/19th. And then he's saying that the inverse, because of the exponential growth, it's a object of a geometric dimension of 0. I quote him elsewhere saying it's geometric dimension of 0, but it's based on the convergence of the rational numbers being strictly less than any positive number, because you're subtracting it from the 1 in the imaginary negative frequency axis, because it's an inverse it's an inverse frequency based on the Pythagorean undertone of the 2/3, because you're inverting the ratio of the 3/2 from the 2/3. So then we go back to, he has this spiral in here, which I never even noticed before, but he's saying that this is the basically the holographic geometric dimension of 0 based on the time and the frequency. And so he calls this the quotient topology. So it's first he's calling it a quotient space, but it's the non-commutative quotient topology that has a dimension, a geometric dimension of 0. So this is the non-commutative chord that overlaps within the non-commutative torus, and so the torus then converges to a geometric dimension of 0 as the 5th dimension. And so now we go back to the original Pythagorean spiral based on the 2 to the 19th and 3 to the 12th, or you could say 3/2 to the 12th divided by 2 to the 7th. And so you can see that this spiral is not, this is before a geometric magnitude as a symmetric measurement. So just as the non-Western scales of the Chinese say that they make this spiral based on using a 5th as yang and then a 4th as yin, and so you have the same non-commutative convergence based on the inverse of the multiplication. So they would say it's, you take 2/3 of a wavelength to get 3/2 of the frequency, and then you take 4/3 of that 2/3 in order to get the 3/4 as a frequency, and then you keep continuing that yin and yang cycle. So when you're reversing the direction of the C here, it is a positive fifth. So this is all, it's 2/3 as a perfect fifth music interval. So it's an infinite spiral of fifths. But in relation to the octave, the F is a perfect fourth going the opposite direction, and that's why it's non-commutative. And so here it's the X means this is for the next octave, that it doesn't line up in the equal temper tuning, and therefore the octaves also do not line up. And so what happens is the root tonic is has a geometric dimension of 0 and as the fundamental frequency, instead of how fundamental frequency is normally defined as a geometric symmetric magnitude or wavelength. So that's why he uses inverse frequency. Let's see if I got any other images available here. But anyway, yeah, I have another blog post on the log, or if I go back, anyway, if I go back to an older blog post, I'm looking through my window. Hold on, let me see if I can, older post. Yeah, so this is not it. Okay, so that's not it. Let me see if I can find it here. So I have the math professor, Micho Durdovic. He's quoted saying it's Pythagorean, transpositions based on the perfect fifth that's non-commutative. And so here we have, this is where I originally figured out the math just a couple days ago, and I guess it was yesterday. And so then, okay, so, alright, I'm going to just keep going here. It should be like one more past. That's not it. Oh yeah, this is it right here. So those are the chords. Somebody else did a lecture on the chords inside the non-commutative torus. And what I found fascinating is if you go back to the original, where the origin of Western commutative math is from music theory, secretly, as math professor Luigi Borzicchini points out. So you can see that the same issue has cropped up again, where they're talking about the chords. You're talking about these non-commutative chords within the fundamental frequency. So that would be your original fundamental frequency as a symmetric magnitude or wavelength, whereby the amplitude is used to define the frequency. But in fact, within that, there are these non-commutative chords. And so this is the original problem that they're trying to deal with, is that the the direction of the frequency as wavelength actually changes the value of the music interval in relation to the octave, and therefore the frequency and the wavelength are non-commutative as long as you're considering the direction of time in the measurement of the frequency. And it's only when they ignored that direction of the time in relation to the root tonic were they able to then convert this paradox back into symmetric logarithms using the wavelength here. So basically the non-commutative analysis is basically going back to a pre-Socratic ancient alchemy that understood this secret of the ratio of two-thirds as a non-commutative undertone to the three halves. So those chords exist within the octave, within the non-commutative torus, and I think I have that in the previous blog post. Let me see if that's in there. No, I didn't put it in there. Anyway, I'll just leave it at that for now, and thanks.